Hello everyone. I'm going to present our initial prototype on behalf of my team DevNova for Arjuna 2.0 hackathon, which is organized by NIT Agartala. So our problem statement is basically building a mobile application which will calculate the total carbon emission emitted by an individual or their families from their daily activities such as transportation, electricity or LPG usage, and their food habits as well, and then provide tips and personalized action plans that the user can follow to reduce the carbon emission further. So without wasting any more time, I'll show the prototype. First, we'll create an account. Um, After that, it is asking for two important things. One is our region, so that it can calculate the carbon emission factor, which differs from region to region. So this is how our UL will look like. So there are many sources of carbon emission, but mainly we are taking into account these four sources. So I'll show you one by one. In the electricity usage, our system will automatically detect the month and the year, but we can also change from here. So right now we have to manually put our electricity usage for that month, same as for LPG. In the transportation section, there are two options. If we have personal vehicle, if we are traveling through public vehicle. If it is personal vehicle, there is a vehicle identification number which is unique for every vehicle based on the region. So the user can manually input the number, or the user can capture the photo and upload it into our system. So if the user captures this is our PPT and I'll show you the flow from here. If the user uploads the photo, our system will use Tesseract, OCR and OpenCV to extract the VIN number. And from that VIN number, using VIN lookup API, official API, our system will extract the necessary vehicle details. For example, fuel type, is it petrol or diesel or CNG, engine specifications, and many other specifications also. And our model, the random forest regressor, will then calculate the carbon emission emitted by that individual by traveling through this vehicle. Another important input I forgot to add is distance. It will also depend on the distance that we have traveled. If the user does not want to manually input the distance, our system can automatically detect using the GPS. One more section is left, which is food consumption. We can add as many items as we want. I'm adding rice and chicken. Alright. We can also vary the quantities. Okay. So as you can see, the total emission, carbon emission is also changing. Okay. So depending on all of these entries and my household size, okay, our XGBoost classifier will classify the total emission generated for 1 month, which is 399.53 kg per CO2. The classifier will classify the emission into high or moderate or low. It is very concerning if it is high. So in case of high carbon emission, our Light FM model will provide recommendation or personalized action plans that we are planning to add under this category. So after suggestions, if the user wants to implement those action plans, they can. So if they do, their new progress will be tracked by our linear regression model. And by using the gradient regressor, our system will calculate the new reduced carbon footprint. And after that, the user can earn badges and celebrate milestones so that they can stay connected with us. So this is basically the overall flow of our proposed solution. And this is a detailed flow of our proposed solution. Here we have also mentioned how we are actually calculating the carbon emission. So one factor which is common in every calculation is the emission factor, which basically depends on the region. So yeah, so this is our overall model. Thank you for watching.